Hi everybody. Welcome to section 8.3. Actually sections 8.3a and b. We're going to do both of them. I hear your groans. It'll be fine. They're super quick. So section 8.3 is all about special right triangles. These are shortcuts. So all you're doing is taking shortcuts. There's very few situations where you have to have them memorized. It pops up every now and then, but for the most of the time you can still use Pythag or other methods in order to find missing sides. So our objective is to learn and use 45, 45, 90s and 30, 60, 90s. So we're going to do 8.3a and 8.3b. So in a 45, 45, 90, we'll start with the easiest ones. The length of the hypotenuse is the square root of 2 times the length of a leg. So if you look at this diagram, here's the length of the leg. It's called n in this diagram. So the length of the hypotenuse you times by a square root of 2. Which means if you've got a hypotenuse and you want to go to a leg, we're going to do the inverse operation, right? We're going to go the other way. So you're going to divide by a square root of 2. You just have to be careful with that rationalizing the denominator business if you're working from a hypotenuse and going to a leg. So really all that is a shortcut. We could do n squared plus n squared equals c squared and use Pythag and we'd get that square root of 2 as well. But it's a shortcut. So memorize it if you want or do it the old-fashioned way if you want. So I'm going to actually add right here. I'm going to say leg to hypotenuse. And over here, times by square root of 2, I'm going to do hypotenuse to leg divide by square root of 2. All right, so let's do an example or two. That's really all it is that shortcut. So number one's a really good example because we start with that 4. Notice it's got the right angle, it's got a 45 degrees, which means what does this other missing angle have to be? I've got myself a 45, 45, 90. So when we're looking at this, we're looking at the angles to decide if we can use a shortcut for the legs. So this 4, is this a leg or a hypotenuse? So if I'm looking for x, my hypotenuse, how do you get from a leg to a hypotenuse? 4 times a square root of 2. It's as simple as that. Remember, we're being precise. We are not rounding, so we're keeping it in that form. Now, number 2, it says to find a. Is our a value on a leg or a hypotenuse? That one's on our missing values on the leg, right? So how do you get from this 8 hypotenuse to a leg? Divide by a square root of 2. So watch carefully. This is where we run into the section 09 stuff. So instead of writing the divide sign, I'm going to put a equals 8 divided by a square root of 2. Write it as a fraction. We have to rationalize that denominator because we are not allowed to keep radicals in the denominator. So I'm going to times by the denominator, square root of 2 over square root of 2. So if I just look at the tops, easy peasy. What's 8 times the square root of 2? One's under the radical, one isn't, so you keep them separate. Denominator, somewhere around here, square root of 2 times the square root of 2, if we're being technical, square root of 4. But of course, everybody's going to simplify that, right? Square root of 4 is actually 2. So I've got 8 square roots of 2 over 2. Look really carefully. If I ignore the square root of 2 and I look at the 8 halves, so you're going to simplify that down. What's 8 halves the same as? 4 over 1, or just a 4. And then you just stick that square root of 2. Basically, variable rules apply. So use the same rules as you would if that was an 8x over 2. You'd have 4x for your answer. So there's one example where we go from a leg to a hypotenuse, one example where we go from a hypotenuse to a leg. So hopefully that'll help you out. Let's do a quick word problem so you can see what that looks like. It says to find the diagonal of a square if the sides are 3 centimeters in length. What am I going to always tell you to do if it's a word problem? Yes, you must draw a picture. So our shape that we're going to draw is a square. What do you know about squares? 4 sides are congruent. It says to find the diagonal if the sides are 3 centimeters. So all 4 sides are 3 centimeters. I'm going to draw in that diagonal with my x. That's what I'm looking for. Do you see if I peel away 1/2 of this, we know we've got right angles. What kind of triangle am I dealing with if I just take the one part of the square, one diagonal? This has got to be an isosceles triangle, right? So this has got to be a 45, 45, 90. So basically, if I take away the square part of it and just look at that triangle, I know a leg, and I'm looking for the hypotenuse. So what will the diagonal equal? 3 times the square root of 2. It was a much easier problem than what it looked like. Everybody okay with that? Let's do one more, actually. Let's look at this one. This is a nice, pretty diagram already drawn. So if each 45, 45, 90 triangle has a hypotenuse of 5 square root of 2 centimeters, find the perimeter of the entire square figure. So perimeter equals is our question. So each one of these little guys is a 45, 45, 90 is what I'm reading from this. So if I take just this blue section out, it's a 45, 45, 90. What do we know about this? It says it has a hypotenuse of 5 roots of 2. And we would probably be looking for one side of that small triangle. We can deal with the other question later. So that 5 roots of 2, is that a hypotenuse or a leg? And we're looking for the leg. So we're going to do 5 square roots of 2. To get from a hypotenuse to a leg, you divide by a square root of 2. This is really convenient, right? What happens to our square roots of 2? Just like if they were x's. Cross out. So we've got ourselves a 5. So each one of these little guys is 5. How do you find the perimeter? Add up all the sides. So what's the length of this side right here? It's got to be those 4 5s. So 20, 20. This has got to be 20 and 20. So I'm thinking the perimeter is going to be 80 centimeters. The perimeter is the easy part. Figuring out that leg is the part that I want to make sure you see. So that's 45, 45, 90s. Times by square root of 2 or divide by square root of 2. That's how you get back and forth. So now flip over to section 8.3b. We're doing this all in one because it's pretty easy. And let's look at 30, 60, 90s. Another shortcut. This is the one occasionally you do have to know it. But I'd say 96% of the time you can still go other methods like Pythag. So in a 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the shorter leg, and the length of the longer leg is the square root of 3 times the length of the shorter leg. Everybody got that, right? Basically, what we're going to do is we're going to always look for the short leg, abbreviated SL. I always know the short leg is opposite the smallest angle. Remember that stuff from that triangle inequality stuff? So if it's opposite the 30 degree, it's got to be a shorter leg than if it's opposite the 60 degree. So short leg is always your starting point. If you're not there, you have to get there. So to get from the short leg to the hypotenuse, you always times by 2. It's just double. That's the easy one. To get from the short leg to the long leg, and the long leg is the other leg opposite the longest or the biggest angle, you multiply by a square root of 3. So now if you wanted to add in there, if you're going the opposite direction from a hypotenuse to a short leg, you divide by 2. Or if you're going from the long leg to the short leg, you divide by a square root of 3, rationalize the denominator. Somebody always asks me, how can I just go from the long leg to the hypotenuse? You can't. You have to go through the short leg. So that's always your starting point. So let's do an example or two. Number 1, it says to find x and y. So we've got a 30, 60, 90. Hopefully you see those all marked really clearly. And the 1/2 is the only piece of information I know. So the first thing I ask myself, do I know the short leg, do I know the long leg, or do I know the hypotenuse? Because that tells you how you're going to move from there. So this 1/2 is opposite the 30-degree angle, right? So this is the short leg. So what do you want to find first, x or y? I heard everybody say x. Is x on the hypotenuse or the long leg? Here's my right angle, so this has got to be the hypotenuse. The y will end up being the long leg. So how do you go from the short leg to the hypotenuse? That's the easy one. That's times by 2. So x is 1/2 times 2, or 1 unit long. How do I go from the short leg to the long leg? That's the one where I times by a square root of 3. So I remember the 2 because 45, 45, 90s have 2 congruent legs, which means I use a square root of 2. In a 30, 60, 90, it's a 1, the short leg, a 2, and a square root of 3. Helps me to remember it has 3 different sides, so a square root of 3. To get to the y, we're going to do the short leg times the square root of 3. So 1/2 times the square root of 3. I would write that as, think of that as an over 1. I would write that final answer as a square root of 3 over 2. So that was just using shortcuts, and I started off by giving you the short leg. So just memorizing or knowing those. Let's skip number 2. And let's go to a nice word problem. It says to find the altitude of an equilateral triangle, the side lengths are 10. Guess what the first thing you should do is? Hopefully you've already got this drawn. What do you know about an equilateral triangle? You know all sides are congruent. What do you know about all angles? Congruent. And how many degrees is each angle? 60 degrees, right? So it says to find the altitude. What's an altitude's one and only job? Comes from the vertex and forms a 90-degree angle. So that means, I should mark that on the other side. If that's a 90 and this guy right here is a 60, how many degrees do I have left for this top angle up here? I've got a 30-degree angle. So if I took this out, took out half of that triangle, here's my right angle, here's my 60, here's my 30, and it says that the side lengths of that equilateral triangle are all 10. So this is 10, this is 10, and this is 10. However, that bottom one got chopped in half, right? So that should actually be a 5, and we could find that with our 30, 60, 90 rules as well. So is the 10 the long leg, the short leg, or the hypotenuse? Looks like the hypotenuse to me, opposite the right angle. This side down here on the bottom is the short leg. This side up here is the long leg, the vertical. So to test my point, how do you get from the hypotenuse to the short leg? There's no easy way to get from the hypotenuse to the long leg. We have to always travel through the short leg. Hypotenuse to the short leg, divide by 2, because we'd multiply if we're going the other direction. So 10 divided by 2 is 5. But it wants the altitude. The altitude is that red line that I drew in. How tall is that triangle? So how do you go from the short leg to the long leg? Times by a square root of 3. So the altitude equals 5 times the square root of 3. We've got ourselves an answer. That's all it asked for, was that altitude that we added in. Look okay to everybody? We can do some more examples. Do the best you can with what we've got. We'll skip. Actually, no, go to number 5. We should go to number 5. So it says to find the missing sides for number 5. Notice it is a 30, 60, 90. First thing, check your angles. 30 degrees, which means this has to be 60 because we've got a right triangle. Is that 5 roots of 2 a long leg, a short leg, or a hypotenuse? Looks like it's opposite the 60-degree angle, so a long leg. This guy will be my short leg, and the triangle's resting on the hypotenuse. So how do I go from the long leg to the short leg? This is a square root of 3, right? We're going from long to short. So I've got 5 roots of 2 divided by a square root of 3. This one is really an ugly one. We got to rationalize the denominator. So I'm going to multiply the top and bottom by the bottom. So if I just look at the numerator, I've got 5 roots of 2 times the square root of 3. 5 stays the same. And my square root of 6, when I times those two numbers together. Down here, this one should work out nicely. Square root of 3 times the square root of 3 is the square root of 9, which obviously is going to become a 3. So 5 square roots of 6 all over 3. So short leg. It's a mess mathematically, but it's an answer. So we just have to rationalize the denominator. The hard part's over. Short leg to hypotenuse, what do we do? That's the easy one. Times by 2. So 5 square roots of 6 over 3. We're going to times by 2. If you prefer to do a 2 over 1 so you can keep your fractions straight, do that. You end up with on top, just do the numerator math. Multiply the numbers, keep the radicals separate. So 10 square roots of 6. Bottom 3 times 1 is 3. So the hypotenuse is 10 roots of 6 all over 3. Not the most beautiful answers we've ever seen, but they're answers. And they've got some messy ones like that in the assignment, so I want to make sure we did one like that. If you've got questions, save them and let's talk about them tomorrow. Otherwise, here's what I've got for you. On page 562, I'm looking at numbers 2 through 24 evens. Word problems, yes, you must draw the diagrams. Don't forget about your signed forms that we need, and quiz on Friday on 09 and then 8.2 and 8.3. So the stuff through today. Have a great day. We'll see you next time.